In this episode, we're going to talk about one of the most powerful security ideas that is also one of the least glamorous: data minimization. Data minimization means you collect less, store less, and expose far less than you technically could. That sounds simple, but it is surprisingly hard because people love having more data just in case. In AI systems, that instinct can backfire because more data creates more privacy risk, more breach impact, more compliance obligations, and more opportunities for sensitive information to leak into prompts, logs, and training sets. Data minimization is not about being careless or blind. It is about being intentional. You decide what data you truly need for the use case. You avoid collecting anything outside that scope, and you design the pipeline so that even when data exists, it is not casually exposed to models, humans, or downstream systems that do not need it. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. The first step in minimization is to define purpose clearly. If you do not know exactly what the AI feature is supposed to do, you will keep adding data to make it work better, and soon you have a data hoarding problem. A clear purpose statement forces a helpful constraint. What is the smallest set of inputs that can produce an acceptable result? For example, if your use case is to categorize inbound security tickets into broad buckets, you likely do not need full identity data, full system inventories, or long historical chat threads. You need enough text and metadata to recognize the category. If your use case is to summarize an incident timeline, you need timestamps, event types, and key entities, but you probably do not need full payload contents or unrelated user profile details. Purpose turns minimization from an abstract virtue into a concrete engineering requirement. Collect less is the first part, and it means you prevent unnecessary data from entering your system at all. In security terms, the best secret is the one you never collected. If you collect a field, you now have to protect it, retain it, delete it, audit access to it, and handle it during incidents. Minimization at collection can include dropping entire categories of information, like not collecting full message bodies when only subject lines are needed, or not collecting raw packet payloads when you only need flow metadata. It can also include redacting at the edge, such as masking PII before it reaches centralized storage. The core idea is that the cheapest risk to manage is the risk you avoided creating. Store less is the second part, and it focuses on retention and duplication. Even if you must collect certain data, you often do not need to keep it forever. Many systems quietly accumulate copies, live databases, backups, caches, analytics exports, and debugging logs. Each copy increases attack surface and complicates deletion. Minimization means setting retention policies based on need, not convenience, and ensuring those policies apply to all copies, not just the primary store. If a dataset is only needed to compute a weekly report, you might keep raw inputs for a short window and keep only aggregated results longer. If a dataset contains sensitive information, you might keep it only long enough to fulfill the use case and then delete or heavily de-identify it. The key is that retention should be a deliberate choice, not an accident. Expose far less is the third part, and it is especially important for AI. Exposure includes what you show to the model, what you show to end users, what you share with vendors, and what you include in monitoring and evaluation. A common beginner mistake is to assume that if the organization owns the data, it is safe to give it to the model. But models can leak information through outputs, logs, or debugging tools. And even when they do not, broad exposure increases privacy and insider risk. A safer approach is to scope model inputs to the minimum necessary fields to avoid sending full records when a summary would do, and to use placeholders or anonymized identifiers when identity is not required. You can also separate tasks so that a model never sees the most sensitive fields, while a different secured process handles those fields when needed. It helps to think of minimization as layers, because you can apply it at multiple points. At the edge, you can filter and redact before ingestion. In storage, you can partition data so that sensitive fields live in tighter environments with stricter access controls. In retrieval, You can limit what context is pulled for a prompt, selecting only relevant snippets rather than entire documents. In output, you can prevent the model from returning sensitive details by default, even if it saw them. When you apply minimization in layers, you are not relying on any single control to work perfectly. If one layer fails, another layer still limits damage. This layered approach is one of the reasons minimization is so effective. It reduces blast radius everywhere. There is also a practical performance benefit to minimization that beginners appreciate quickly. Less data means faster processing, lower cost, and less complexity. For models, smaller prompts are easier to manage and reduce the chance of missing important context in a flood of irrelevant detail. Minimization can reduce hallucinations because the model has fewer distractions and fewer opportunities to misinterpret noise. It can also reduce prompt injection risk because you include fewer untrusted documents in the context window. This is an important point because it shows minimization is not only a compliance or privacy goal. It directly improves reliability and security. When a principle improves both safety and functionality, it is usually worth adopting. A common misunderstanding is that minimization means you cannot do good security analysis. In reality, security teams already use minimized representations all the time. Instead of storing every packet payload, many teams store flow records, summaries, and alerts. Instead of keeping every raw event forever, they keep certain key events longer and discard others. The art is deciding what is high value for your use case and what is not. For AI systems, you might keep raw evidence in a secure vault for investigations while feeding the model only a derived summary and the minimum metadata needed to reason. If deeper analysis is required, you escalate to a human or to a controlled process that can access the raw vault. This is how you keep the AI system useful without turning it into a bucket of everything. Minimization also connects to fairness and bias in a way beginners can understand. When you collect excessive personal details, you increase the chance that a model will use those details inappropriately, such as making assumptions based on department, location, or other attributes that are not relevant to the security question. Minimization reduces that risk by removing irrelevant personal attributes from the model's view. It also reduces the chance of accidental discrimination in downstream decisions, because the system simply does not have the extra data that might tempt biased reasoning. In security, you want decisions to be based on evidence of behavior and risk, not on identity. Minimization supports that goal by shrinking the data footprint to what is actually needed. Another practical technique is to use derived features instead of raw data. A derived feature is a simplified representation, like the count of failed logins in a time window, the number of unique destination addresses contacted, or a classification label like high-volume scanning. These features can be very informative for detection and triage while containing far less sensitive detail than raw logs. They are also easier to validate and less likely to leak secrets. The trade-off is that derived features can hide nuance, so you design them carefully and keep a path to raw evidence when needed. For a beginner, the key idea is that you can often achieve the value of data without keeping the full sensitive content by computing a safer summary and discarding the rest. By the end of this episode, the takeaway should feel like a disciplined version of common sense. More data is not automatically better, especially when AI is involved. Collect only what the use case needs, store it only as long as you must, and expose it only to the components that truly require it. Apply minimization at multiple layers so that even if one control fails, the blast radius stays small. Use anonymization, placeholders, and derived features to preserve analytical value while reducing sensitivity. When you practice data minimization, you are not just protecting privacy and compliance. You are making the AI system easier to secure, easier to audit, and easier to trust, because there is less sensitive material inside it waiting to become a problem.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.